everyone, my name is Luyando Mbozi. I'm an environmental engineer and I'm also a trustee at Global Association for Transition Engineering, GATE. My presentation is on energy transition in Zambia. The presentation layout is as follows, just to give you an idea of what I'll be talking about. To start with, I'll start with the background and then Zambia's commitment to emission reductions, key categories and sectors contributing to Zambia's emission profile, energy sources used in Zambia, fossil fuel consumption, energy transition projects in Zambia, energy transition hurdles, and finally the conclusion. Zambia is a landlocked country in southern Africa with a population of more than 19 million people, and its major economic activities include mining, agriculture, and tourism. Zambia is committed to reduce greenhouse gas emissions and is a signatory of the Paris Agreement of the United Nations Framework Convention on Climate Change. On 9th December 2016, Zambia submitted the first nationally determined contribution and pledged to reduce emissions by 25% with limited international support and by 47% with substantial international support. The reference indicator, the year 2010, had a level of emissions of more than 120,000 green gas emissions, carbon dioxide equivalent. The three key categories and sectors contributing to Zambia's emission profile are 1. Energy, manufacturing, transport and construction industries. 2. Agriculture and forestry. 3. Waste category, which includes solid waste disposal, incineration, wastewater treatment and discharge. If you look at the screen on your right, you find the total energy consumption by sector. And if you notice that the mining sector consumes more than 50% of the energy in Zambia at 54.5%, and the construction industry consumes the least energy at 0.09%. Energy sources used in Zambia is mainly the wood fuels, which 70% of it is used. Unfortunately, this also contributes to deforestation in the country. And then the next energy source commonly used in Zambia is electricity at 14%. Then we have petroleum at 12% and coal 2%. Other sources of energy used are at 2%. Fossil fuel consumption in Zambia is on the rise, and according to the Energy Regulation Board, petroleum products are on demand at 52 million liters per month. If you look at the graph, you notice that between the year 2019 and 2020 was exceptional in that there was a reduction in petroleum consumption in Zambia. This can be attributed to the COVID-19 pandemic, where there were travel restrictions, and thus the petroleum consumption went down as well. In order to shift the primary reliance of fossil fuel from a global system to renewable energy, the following energy transition projects in Zambia are underway. We have the expansion of the hydropower generation, rural area electrification projects, solar energy, connected solar mini-grids, solar off-grid solar solutions, wind energy exploration, and geothermal wind. I'll discuss these now in detail. The three major hydropower plants are actually undergoing rehabilitation, and these plants are Kariba North Bank, Kafue Gorge, and the Victoria Falls. Currently, the generation capacity of hydropower is at 3,356.6 megawatts, but the capacity potential is at 6,000 megawatts. And with the full capacity, Zambia is able to meet all its energy requirements and needs. In addition to the hydropower plants, there are 7 mini hydropower stations that generate 4.2 megawatts of power, and that contributes to 1.52% of the national grid. A comparison of the grid-connected renewable systems between 2022 and 2030 is that in 2022, there has been use, or since 2022, there has been use of fossil fuels such as coal and heavy fuel oils in the generation of power. But the target is in 2030 is to eliminate the use of fossil fuels and also introduce more energy, renewable energy sources of energy, such as wind and thermal energy. Another transition energy projects are the connected solar mini-grids and off-grid solar solutions. There are currently 3 major connected solar mini-grids, which are Bengueulu Solar PV plant, which generates about 54 megawatts of power. Then Ngonye Solar PV plant generates 34 megawatts. CEC generates 1 megawatt, but is currently undergoing expansions so that it can be able to generate 33 megawatts of power. The total power that is expected to be generated by 2024 by the connected solar mini grids, it's 220 megawatts. In addition to the connected solar mini grids, we have the off-grids solar solutions, which there are more than 10 in the country, and these operate mainly in rural areas. So the off-grid solar solutions produce electricity, and these are directly consumed by end users or consumers, as opposed to being put up on the grid. Wind, geothermal, and biofuel energy generation is currently being explored. There are 7 areas identified as viable for off-grid wind power generation, and there are 341,000 units of biogas digesters producing ethane as a source of biofuel energy. Kapisha Hot Springs has been constructed as a pilot project for geothermal energy production because Zambia has got more than 80 hot springs. Rural electrification project is being done by the Rural Electrification Authority, which was enacted in 2003. Their mandate is to increase the access of electricity, especially to rural households. The target is that by the year 2030, at least the rural electrification rate is going to be 51%. Also, the Rural Electrification Authority's mandate is to design and offer subsidies for capital cost of energy supply projects in rural areas. Most of these energy supply projects, are currently solar. And if you look at the map of Zambia on the right, you see the distribution of access of electricity across Zambia. And on average, household electrification rate is going on at 20.3%. Of that, in urban area, that is 47.6%, and in rural, it's only at 3.1%. The energy transition hurdles are as follows. We have economic and financial barriers because setting up a renewable energy system is an investment which involves scaling, and it's quite expensive. And then we have ever-changing renewable energy technologies, which means that we have to constantly develop and revise standards, codes, and guidelines to keep up with the changes. The weather conditions and time of the day also affects the generation of power and energy, and also storage of this energy is also a challenge and needs to be considered. Knowledge and awareness gaps also exist between the energy suppliers and also the consumers. In conclusion, energy transition in Zambia is necessary in order to reduce greenhouse gas emissions. Efforts are being made to attain the NDC 2030 targets. However, even if these targets might not be met in 2030, there's still a reduction of emissions. Also, energy policies and regulations have been put in place to ensure energy transition. Thank you so much. This is the end of my presentation.